and yeah, it's as big as it sounds.
Yeah.
So, and it will be good at one thing that we know for sure, producing a lot of data.
There is here with me Yuri, so please introduce yourself and let's get started.
So I'm Yuri Pidopryhora. I'm a scientist at Max Planck Institute for Radio Astronomy in Bonn, Germany. And well, I'm involved with interTwin, obviously. So
Yeah.
that's the reason for me being here.
And I suppose with Radio Astronomy as well. So
yes, and like I'm doing radio astronomy for basically all my life.
Right, cool. So one question that comes immediately to my mind, and I suppose also from people that are looking at this, how radio astronomy and digital twin talk, or what's the use case for interTwin in this case?
So for interTwin, well, our motivation for joining interTwin was that we are encountering right now the radio astronomy is at a very important junction of its history, that we're about to launch a number of very big telescopes. Specifically, the most important is the Square Kilometer Array,
Right.
DSK, and yeah, it's as big as it sounds.
Yeah.
So, and it will be good at one thing that we know for sure, producing a lot of data.
All right.
And basically, first time in the history of radio astronomy, we will not be able to keep all the data we want, because previously the idea was that the data is sacred, and so everything that you observed, you spend money observing, so you keep it. That's it. That like you put it somewhere, there is archive, there are tapes or whatever, and you still can go to the data of like 80s or 90s and recover it and do whatever you like. So this is no longer possible, and that's a major paradigm shift for like decades of radio astronomers who are working on like that. And right now, you cannot do it anymore, because the new telescope will produce so much data that even the best institute will not be keep it even for a month.
So exactly. So you will need some.
So we need some methods to sort through it quickly and preferably automatically.
Okay.
And
so you will have, as I understood, some centers that are dislocated with a full set of data, or how you managed such a.
So the data comes from the telescopes, and then it should go somewhere to be processed. Right. So there are a number of institutes in the world. Sometimes they're associated with a particular telescope or observatory. Sometimes they're independent. So right now in Germany, there is a new institute created last year, the German Center for Astrophysics, abbreviated as DCA in German.
Okay.
And it will be specifically dedicated to processing large amounts of data coming from new telescopes.
So we can say that more than a generic digital twin needs, you share the amount of the management of this kind of data.
So the digital twin comes into this equation because we need to work with it. We need to simulate the data coming from the telescope, because when you're already observing, you're already spending money. You're running. It's already important, and all the data may contain something important. So you want to play in advance with something, change parameters. So that's why you need the digital twin of the telescope of observing a particular object.
Yeah, you better be sure that it's good what you say, right?
Yeah.
Okay, so next question I have is, how was your experience with interTwin, with the project itself? What you find useful also for the follow-up that comes next, and these sort of things. And essentially, I'm curious to understand, in this situation where you are essentially planning for the future, how initiative like this can be of help for the science use case.
So, well, first of all, my experience was very positive. Actually, surprisingly positive. I'm pessimistic about these things. So when I start something like that I thinking, "Oh, we're gonna fail." I mean, that's a waste of time or something.
Yeah,
But no, that's actually was very productive, and we achieved a lot, and we've created useful tools that are fully operational. That we are right now releasing the full production version 1.0.
Cool.
So everything is working, and a lot of useful things were done. So
good. Yeah, nice.
so as for the future and the general use, first of all, this is not limited to radio astronomy. I mean, we are radio astronomers, so we do what we know how to do. But the similar situations, for example, in particle physics, so they also have accelerators, new experiments that going to be produce tons of data, and this method is universal. But even worse, there is this thing called Internet of Things, IoT, the new concept that like everything, like any gadget, any home appliance gonna be, and we already have this right now, that they have Wi-Fi capacity, they can connect to each other, they can talk to each other, to your phone, to your computer. And so we're gonna live in a fully linked world, and that thing, all that will be producing data. A lot of data, and we need to know how to deal with this.
And it's a very interesting point because it's the very core of the interTwin project, right? Bringing all these use cases that share a common needs together to create something that can be useful for everyone. Yeah, very nice. Would you change anything about the project or any kind of problem that you faced initially, maybe terminology wise? What kind of difficulties?
Well, terminology wise, I'm an astronomer, so we use terminology that was developed like 2000 years ago. So it's like, okay, so you name something, like, let's just agree that it's named. So I'm not worried about terminology, but the only thing I want to change that right now interTwin is ending. It's just 3 years. So if I could, I would extend it. Because, I mean, we're doing good work. We should continue working.
Yeah, I see that. So, and for making people aware of what does a solution that, well, make clear how interTwin help you developing and finding solution for your needs. Do you have any use case or any link or any reference that we can also put in this in description if you wish, or that highlights the contribution for your use case to interTwin and interTwin to your use case?
That's
hard.
that's a difficult question.
Because I see there are multiple. It's not one thing, right? So it's a contribution of different stuff. So I just wonder if there is anything on top of your mind, or even afterwards, we can put in the description. So that's
no. I mean, that was in many respects it was a learning curve. So we've been learning new things of how to, for example, the German Center for Astrophysics that I mentioned, that it has right now a lot of hardware that it's been built, and it creates infrastructure, and then it has to join it was like various project data banks and so on. And interTwin is exactly the model that for how this can be done. So this is, and we already doing this. We're actively using interTwin example of connecting all these unrelated scientific users together, and linking it with infrastructure, with hardware, which was like supercomputer centers and so on. So
I agree.
This has already been used. So I think this is the best example. So in this new German Astrophysics Center for Astrophysics, it's already been used. interTwin has been used as an example for how you can deal with this situation.
So it was okay. I see. It was building a model.
Yeah, it's like a template, basically.
Yeah, exactly.
And a block of ideas and So not necessarily used exactly like that, but look at how it was done and maybe using something based on the same pattern.
Nice point. Nice point. Yeah, I agree. Very good point. So yeah, I think I have to thank you for your time, for your experience, for your point of discussion. It was very, very, very nice. So
I think it went better than I was afraid.
No, come on. Okay, so thank you. Stay tuned for more episodes on other use cases, and see you on the next one.